The next thing we are going to do is go a little bit more into the Entity API and to also add a little bit of styling and interactivity to our app. So Luke talked about the Entity API before. This is basically parts of the library that you can use for adding different types of geometry, so say like rectangles, or we used it to add a model, but it also lets us go in and edit data sources, certain data sources that we bring in, such as the GeoJSON that we loaded in the last step. So, to start off, let's actually jump back to the first part of the app where we created the viewer. And I know somebody earlier asked me about the info box true and whether that mattered or not. Let's add that to our first statement for now, and I'm going to explain a little bit about what it does. So, shoot, all the way back up. And then we'll jump back here. Now, if you jump back into your app and you try clicking on something, like say this big polygon right here, you should see a box over on the right-hand side, which is basically spitting out all of the metadata that is associated with that polygon. So since we loaded GeoJSON, GeoJSON has the geometry data in it, but it also has a lot of properties in it, specifying things like here we have, we can see the name. It says Friends of Liberty Park. A lot of times it'll have IDs. They're usually some sort of characterization. For instance, here we can see it's a city park. So what this info box is, at the end of the day, is basically a way of kind of debugging or just inspecting some of the information that comes in with the feature. So, and then if you're also interested, if you click on any of the buildings in the 3D tile set, you should get something similar as well. So in this case, this is pulling in metadata from the 3D tile set. Kind of similar in principle, right? Like it's a bunch of properties and their values. So in this case, we have things like an estimated height and like the latitude and longitude information. Different data sets will specify different properties. The info box is a great way to just kind of see what you have at the end of the day, right? And based on the metadata that's here, what we can do is add interactivity, add styling, modify our app to make use of that and make that data valuable to the user, right? So, let us then hop back to our app. Let's see. So we are going to use that metadata to first style our polygons. And one of the things we do when we're going in and adding styling, we want to make sure that we are adding color in a smart way. Sure, it's fun to just kind of like throw every color at a map, but at the end of the day, if you want it to be useful, that color needs to mean something, and it needs to be visible, and you need to be able to tell the difference between different values, right? So a great tool that I use a lot is a place called Color Brewer, colorbrewer2.org. These are the Color Brewer palettes. And there was a data scientist who basically went, I think her name is Samantha Brewer, and curated several different types of color ramps and color sets that are really great for geospatial use cases. A lot of them are colorblind accessible and otherwise like print accessible, so it's a great resource for pulling different colors that you can use. Namely, though, there are 3 different types of palettes that she groups things in, and these are a great way, depending on your use case, to pull different palettes. So first is sequential. That is really good for like when you're talking about like, hey, I'm interested in a data value that like goes from like 0 to 100. So say I'm interested in like, hey, % of the population that does X. Sequential is a really good way to show that. So areas where it's a low population, you use a light color of the palette. Areas where it's a high population, you use the dark color of the palette. Either extreme, right? Then there is one for diverging data. This is a case where you have a property that you want to display that has kind of different extremes. Like a typical use case would be like percentage of people that vote Republican versus Democrat, right? You want to show one in red, one in blue, and then in the middle you want like a neutral value for areas where it's mixed, right? So that's a great use case for a diverging color palette. The last one is called qualitative. And qualitative is good when you have a lot of distinct buckets for data. So it's not really about a range of different values. It's more like you have a couple different categories or a couple different buckets that you're throwing your data in, and you need to be able to tell the difference between them, right? So what we had in our app, when we pulled up the info box with the metadata, one thing we had here was a category for the different types of parks. That's what we're going to use to style our polygons. And since they are category data, there are different types of parks, like public parks, private parks, different types of ownership. We are going to use a qualitative color palette in order to display them. So we've gone ahead and picked out one, I think it's like the third one from the left. But if you want to go to colorbrewer2.org and pick your own, please feel free to do that. So we are going to jump to our app and add a function that will take in the category name and then spit out the color that we want to use, right? So I'm going to jump back over to Visual Studio. I'm going to go back to main. Let's see. There we go. The 3.1 step, and there's also the link there if you need it. And I'm going to actually paste that right after the GeoJSON data source reference. So this by itself doesn't do anything. This is just defining the function that we're going to use later. But if you want to replace any of those colors, what you're going to need to do is those highlighted areas, just replace the hex codes with the ones that you're getting from the website. So if you're trying to customize it all, swap those out. Notably, we also left a default category for anything that just kind of falls through. For some reason, it doesn't have any category data in it. We're just defaulting to a gray. Then the next thing we are going to do is actually apply that palette to our data. And the entity system, the entity API, which I talked about before, the data source API that we use to load the GeoJSON data builds on top of that. So we can jump into it, pull out the individual entities, and then iterate through them all in a for loop and make modifications. So that's what we're going to do in this step. Oh, one thing I forgot about too. We're also going to turn down this map layer saturation, map layer contrast step. What we're doing here is tweaking the color of the base map in order to make sure that the polygon data and the styling that we're doing kind of pops against it, just to increase some visibility. So that's what those two lines are doing. If you're interested, you can kind of play around with those and see how they affect the visualization of the base map. But once you have that in place and then you refresh, you should now see your map, but with different colors. So now you can see that we are pulling in the color data that we were using before. And as I navigate around the scene, you can see parks in different colors. So you can see this one's a light blue, this one's a green, this one's a dark blue. They're ending up with different types, right? So this is a city park but developed. This one is a different ownership. So this is SSFUSD owned sites. I'm not a parks expert. A private park, which we marked in red. So you can see there that makes it very easy for somebody to come in and see the different types of data instead of them all being like one base color, right? Now somebody can tell at a glance, hey, these are different categories. There's a lot of other styling options you can do. For now, we're just altering the color, but if you want to explore the API, there's tons of stuff you can do. You can add outlines, you can extrude polygons so they become like 3D shapes. I would encourage you to play around with that at some point. And the next thing we are going to do is add labels. So we have that data populated, the GeoJSON data, with stuff we probably want to make human readable at a glance rather than having to click on each individual polygon. So what we're going to do is pull out that data and create new entities, which will be the label data. They will show the metadata as just, a label. In order to do that, the code is very long, so I did not copy it into these slides, but it is this code right here. So starting at step 3, we have a function that will grab the polygon center. Then we have another for loop, which is iterating through all of the entities. And what it is doing, let me copy and paste it, and then I'll go back and talk through it. What it is doing is, once again, iterating through each of the entities, going into the metadata, and grabbing the, I scrolled up too far. It is using this function we defined here called getPolygonCenter to pull out the individual positions that are kind of go the outside ring of the polygon, and is doing a very simple calculation. I think it's just averaging the locations to get a new position where we want to put the label, right? Because the label can only be at one position. Then using that position, that's how we define the center. We are also pulling out a few other things. We're pulling out the category value again. We're doing that to color our a point that we're adding at the source of the label. And we are once again calling the getCategoryColor function in order to pull that data out. And then we are adding a new entity, which we are creating. It has a position property with that center value that we calculated. It's adding a point, which we are specifying various properties for, including the color that we pulled out. And then we are also adding labels. And if you can see here, the operative line that's probably most important here is text. And we are setting the text property to the entity property value of face ID. That is the property that we are pulling in and using as the label text. Yes?
Is that the property that is being labeled? Or?
That is the property. So this is labeled as Sign Hill Park, right? If I click on this, this is the entire polygon. This is all of the metadata that's associated with that polygon. And then we're going to use the property name face ID And then that line of code, what it's going to do is for each of the polygons that we're iterating through, it's going to check the value of that face ID property. In this case, it is Sign Hill Park, so you can then see the label gets populated with that value, Sign Hill Park.
So that's basically the field header.
Yes, I'm not familiar with field header specifically, but it sounds like it's in the right direction. Yes, exactly. Yes. Yes. So properties can, a lot of times properties are static values, but they don't have to be. Sometimes they can change based on time. Very commonly, say, like position changes by time. So you have an aircraft that's flying around. What the entity system does is allow you to pass in the current time so you can evaluate what the value of that property is at that specific time. Here, we're just passing kind of anything. I think we're passing now or the current scene time because it's a static property, it's not changing. But if you're, say, doing like something more along the lines of like a flight tracker where you have data, then they're flying and it's updating, you're going to want to make sure that you're using the current scene time to pull out that value so that it's updated, right? It's the correct value at that current time. Yes? Yes. So when you're talking about the pop-up, are you talking about this or this? The top one on the top right? Yep. That is at the, 1 second. That is all the way back up at the top. And then if you go to the line here, this info box property needs to be true in order to see that. Yep. So we are using a lot of various properties here to style the point and the label. The important ones I want to point out are height reference. You'll notice that we're telling it to clamp to ground. A lot of times, especially if you're pulling in more traditional like GeoJSON or geospatial data, it doesn't have height data associated with it, right? So what clamp to ground does is it's going to use the height of the terrain or other elements in the scene at that position in order to kind of snap it to the ground, right? So that's useful if you have something that doesn't have height data with it. Some other things that are useful here are you'll see things like scale by distance or translucency by distance. Anything that says by distance is basically a way of modifying how the label looks or the point looks based on the distance the camera is from it. So a lot of times what happens is you zoom out and your map gets really cluttered. Right here, we're fading the labels out when you get past a specific distance. So it just kind of cleans things up, makes it a little bit more user-friendly, right? And same thing, I think, with the points. No, we leave the points there. But yeah, we're scaling it, so we're making it a little bit smaller when you zoom out, and we're also fading it out. And those properties will let you define kind of the distance away at which that's going to happen.
What property was that?
Those are anything that says by height. So let me pull it back up. Or by distance, excuse me. So like scale by distance or translucency by distance, those are the properties you want to look for. Yep. Cool. And then one other thing I wanted to point out here is, I mentioned we're getting the center of the polygon. We're doing a very simple calculation to do that. We're averaging all the positions together. There might be times when you want to do operations that are a little bit more robust or advanced or have a specific purpose. you can pull in different geospatial libraries, anything that is available in Cesium.js, and use it alongside Cesium.js. So for example, it's very common to pull in a library called turf, which is really good for manipulating GeoJSON data. For instance, if you wanted to do a little bit more of a, I would say like cartographically accurate center to a polygon using, they call a center of mass calculation, but it's also called the centroid. You can pull in the library in order to do that. We're not going to do that here, but I just wanted to mention that that's an option. There's a wide variety of other geospatial tools in the ecosystem that you can pull in and use alongside Cesium.js. It's not like an either-or situation, right? So if something's not in Cesium.js, Cesium.js is very oriented towards kind of the runtime visualization and the data streaming portion. But if you want to do some more interesting cartographic, magic manipulation, then there's a lot of other good libraries out there that'll do similar things. So I would say give it a look, explore, see what's out there. Next up, we are going to talk about picking. So picking is a word that comes from like more of a graphics background. So that's the word I'm going to use here. And it basically just means the ability to basically point your mouse at something and have the renderer be able to spit back what you just clicked on, right? So given a position on the screen, what is there? We call that picking. And if we go to Visual Studio, we are going to implement a function that allows you to mouse over a polygon, and then it will give you some more information about it at a glance. And we're going to format it a little bit nicer, maybe filter out some of the unneeded properties that we were seeing in the info box, and display it in a popover for the user. So this code is everything step 3.5, handle custom picking, everything down through that function, down to the last call to add custom picking right before step 4.1. And what this is doing is first, we're going to add an additional entity that we're going to move around the screen as needed. And we're going to hide it when it's not being used. So this is more of a dynamic entity than the entities that we've worked with so far. And this is basically going to be the container for the information we want to show to the user. Then we're going to set up what we call a screen space event handler. This is basically functionality that will watch for different kinds of interaction. We're going to watch for mouse movement, but you can also watch for things like mouse clicks, right clicks, taps, different key bindings. If you want to hook up like a controller for something that you might use for like game purposes, you would set up a event handler in order to handle that input. But for now, we are just going to set that up to be mouse movement. So we are going to set our input action, and this entire function you're going to see is what happens when that event happens, and then you'll see right at the end the actual type of event that we're watching for. So this is mouse move. And then the body of the function is what happens when the mouse moves, right? So this first line, pick object, the viewer.scene.pick function. What that is doing is the meat of picking. That is taking what we specified movement and position. That is going to be the position that your mouse is in once you've moved it after it's done. We are going to use that position on the screen feed it to the function. The function is going to do some smart math to take that position on the screen, orient it into 3D space. It's going to cast a ray from where you are from the camera down to the scene, and then what it intersects with is what it is going to pick. So it is going to pick the polygon. Yes? Do you have a question? Oh, sorry, I thought you said something. And what we want to do is first check that, one, our mouse is over something. So we check here with the define function, hey, is something actually picked? And then we want to check that it is valid data that we want the user to be picking. So in this case, we want to make sure that it has an object ID. Next, we want to make sure that that entity is part of our GeoJSON data set, right? We don't want to be picking the model that we put in. We don't want to be picking like the buildings that are in the scene. We only, for our purposes, we only want to be picking the GeoJSON data set. So we're calling the contains function just to make sure. And then, once again, we are setting up a position in order to show our popover label. And we are once again calling the getPolygonCenter function in order to do so. And then we are dynamically setting some properties of that entity. So we're setting the position property. We're setting the show property to true, so we actually want to see it now. And then we are populating it based on properties of that object that we just picked. So we're pulling out the park type and we're pulling out the acreage here. And these are based on class and acres. These are going to be basically the header properties. I forget exactly the term that was used over here, but it's going to be that property name. And then once again, pointing out that like we're calling Julian date here now because in some cases you might have dynamic data, but everything here is static, so we're just using current date. Don't worry about it. And then lastly, we are setting the label text to be a nicely formatted version of what we just pulled out. So that's a lot, but when you're done, it means you can mouse over these and it's going to pop up with that information that we just pulled out there. So as we move around to different parks, you'll see different headers pop up. And then lastly, since now there's some redundant data on the screen and up in this popover over here, we can set info box to false in order to hide that, and we'll just rely on the mouse over picking that we just implemented. So if you jump back over to Visual Studio, scroll back up to the top, and modify that info box property to be false. Save it and refresh. That means now when we're clicking on stuff, it's not going to pop up anymore. So that just kind of cleans up our app a little bit. All right, so that's picking. The next thing we're going to do is go over different ways of controlling the camera and kind of navigating around the scene, and we're going to go back to Luke for that.
Right. So we'll let me bring up the slides here. Okay. So yeah, this is the last section of the Cesium.js portion of the workshop, and we'll get a little bit into it's doing some fun stuff with the camera. Cesium sitting in this cool spot between geospatial and a 3D engine. There's cool stuff you can do with the camera. So we'll show a little bit of that, give a taste of that. First, a brief aside, more on the geospatial side, is just a quick word about geocoding. So for those who don't know, geocoding is where you basically you want to go from a text location, whether that's an address, the name of a location, or the name of a place or a restaurant, something like that. You go from that into geospatial coordinates. That's what we call geocoding, and it's basically a geocoding service is basically something that takes in a text location and will look up in some sort of big directory and then give you the geospatial coordinates. So just want to point out that we do have a geocoding support in Cesium.js in the viewer that we're working on right now. So if you can bring that up in your app. If you look here, this is our geocoder widget. It's something that comes with you in Cesium.js, and you can turn this off if you want to not include this in your application, like you can all the other widgets. But it's something that's up here. So yeah. Oopsies. Yeah. So you can go ahead and you can just do a quick search like that, and you'll see that it'll navigate. It uses the fly to functionality that we with a duration of not 0, so you actually get the animation to take you to the location that you've asked for in a geocoder. By default, the geocoder uses Cesium Ion. So Cesium Ion, in addition to all the stuff it does to tile and serve up data, there's also a geocoding service as part of Cesium Ion. You can customize. If you have a specific geocoder you like, Esri or Google or whatever, of all the different options out there for different purposes, you can go ahead and you can use that. We have support for that in the API and examples on how you can swap in different geocoders for your application. So cool. So that's geocoding. I don't know if we have any questions there or anything, but yeah, that's already in your app, already baked in. And it's something you can turn off if you want. So all right, with that. Oopsies. Yeah, so we'll go to basically our final feature that we'll do in the workshop. And yeah, so what we're going to do is we're going to set up ability to just orbit a point. So what do we mean by this is so what we're going to do here is we're going to take our camera and we're going to point it at something, and then we're going to orbit around it while keeping focused on that thing. So what we're going to do that around the balloon that we plotted in our scene in an earlier step. So let's go ahead over to the code. All right. So we are. Okay. So yeah, we're on step 4.1 now in our code, yeah, so what needs to happen here, we want to be able to toggle on and off the orbit just for this case. And we're going to have it so that it's controlled by just a key press. So in this case, we'll use the Q key. So when the user presses the Q key, that'll turn on this orbit animation. And then when they press it again, it'll turn it off and return us to the original scene that we had. The original orientation and position of the camera. So yeah, so here's our code and what we'll grab. All right. So we have this toggle orbit function, and we're going to be adding. We're going to add that function basically to respond to the key press. So we're going to add an event listener. Which we're going to add sort of a standard event listener to the key press of the Q key. Right. So we'll go down to the bottom of the app to put this in. Here we go. Scroll down. Oopsies. All right. All right. Way down to the bottom. Okay. Okay. So just do a little bit of a walkthrough here on what we have here. So I'll start here. So we're the key down document add an event listener on a key down, and then we're checking to see if that's the Q key. This is this is standard to JavaScript in a web browser, not specific to Cesium.js. Like any event listener that you'd see in a client-side code. So that's what we're doing here. So, but every time we have that key press, we're running this toggle orbit function, and that's where we get into the Cesium JS code here. So, if the orbit handler is defined, if it's already orbiting, if it's not orbiting, then we're going to turn on the orbit function. And what we're doing here is we are we're just positioning the camera. So we're setting, similar to how we positioned how we position entities and how I position the camera at the beginning of the scene. We're setting a pitch, we're setting a range, how far back we are from the thing we're looking at. We're setting, and then what is I think is going to make this orbit happen is that we are going to calculate a heading, and we're going to change the heading based on time. So as the scene loads, when the scene loads, that's sort of the beginning of time. And as time passes, we're going to calculate the heading based on that. So as 1 second passes, 2 seconds passes, 3 seconds passes, we're using that to calculate the heading so that it gives the effect of the camera rotating around. And we're passing this heading calculated on time. We're passing it into this camera look at function. So we have it in there. So let's bring it up. So here we have it in our scene, and so I press the Q key, and now we have this orbiting effect. And then you press the Q key again to stop it. So again, you can toggle it off and on. And I'll just point out one more thing in the code, which is how are we, we're recalculating the heading, and we're doing it. How do we hook into the render cycle so that we can change the heading each frame? We do that using this pre-render event hook right here. So pre-render basically lets you add a listener, add a function here via listener, which you can run every time the scene is rendered. So you basically run it before each render. So whether you're running 10 frames per second, 30, 60, whatever, before each render, you're going to be able to run the function that you specify here. So each time we're rendering the scene, we're calculating how much time has passed, and then how that should dictate the change in the heading to create this orbit effect. Cool. Are people? Question? Yeah.
On a range constraint, can that be set on a mouse control so you can zoom in and zoom out while you're orbiting?
Yeah, totally. You can. So basically, you're running this function every cycle, and you can pass in different data. So in this case, the only thing we're really paying attention to is time, but you can pick up different things that you have available to you in the browser. Things like mouse position and
So if I want to zoom in on the balloon and get close and then maybe back out dynamically during the animation.
You can pass in different. You can basically just pick up the different things about mouse position, and it's all in the everything that's available to you in JavaScript is available to you there. So. Cool. 5 minutes, perfect timing. Unless we have more questions, I'll go to the last little bit here. All right. So finishing touches. That's it for our features. So the last thing that we wanted to sort of leave you with was a few extra kind of if you are feeling good about everything we covered and you want to push yourself a little bit further, using all the demo, using this demo app that we've created so far, we wanted to provide you with some ideas. This is also sort of like the stuff that was cut that we couldn't fit. So so here's some ideas, and again, we're going to be here the rest of the day, rest of the conference, so you can come talk to us about it if it's something you're interested in, and we can help you with it. So Here are ideas for fun next steps, optional, of course. So adding animations to the 3D model. Right now, the balloon is sitting up there near the coast. But yeah, what if you wanted to animate it? In reality, like a hot air balloon is going to be like, on some journey moving around. So that's a cool thing to do is you can basically specify a path for that balloon to follow. The balloon could orbit in a circle. The balloon could it could just follow the coastline or go some direction. It could go up north towards the Golden Gate Bridge and then come back. That would be a cool thing to add, is adding a animation to the model in that way. So that's number one. Visualize shadows. You can. There's more you can do to visualize shadows based on the terrain, based on the buildings. We have API support for that. Didn't have time to show it. That can be a very cool thing to add. You can also terrain, buildings, also the model. 2 minutes? Okay. All right. All right. You can add custom raster imagery, and you can add new picking behaviors. I think there's probably a lot of ideas for different interactivity that you can have through picking behaviors and different. There's a whole world out there of raster data sets, and you can create your own, load it in Ion, and then bring it into the app. So, all right, those are the extras. That's it for Cesium JS. I'm not sure who I handed off to now. But yeah, maybe some final words also from Gabby. Yeah. Thank you all.